This unit is all about the idea of being similar, which is distinct from congruent in that congruent means same size, same shape. Similar just means same shape, but they can be different sizes. We talked about this briefly before, but we're going to go into a lot more detail now. So the technical definition here is similar polygons are two polygons with congruent corresponding angles and proportional corresponding side lengths. So similar figures will have the same angles and they will have different sides, but the sides will be proportional. So for example, ABCD is similar to EFGH. Notice that similar is like congruent, but it's one line instead of two lines. So one wavy line instead of two wavy lines. The corresponding angles, angle A and E are congruent, B and F are congruent, C and G are congruent, and D and H are congruent. And then the ratio of side AB and side EF is equal to the ratio between BC and FG, CD and HG, and DA and HE. So the sides are proportional. So if you set up a ratio and did this number divided by this number, you should get the same thing as when you do this number divided by this number, and so on. So like if this is twice as big, this divided by this would be 2, this divided by that would also be 2, for example. So for this diagram of these two triangles, we're going to list all the pairs of congruent angles first. So A and we're told that they're similar. Angle or triangle RST is similar to triangle XYZ. So that means that angle R is congruent to angle X. And I can tell that first because they're in the same position, and second because of the way this is written, R is the first letter and X is the first letter, so they match up. Angle S is congruent to angle Y. And angle T is congruent to angle Z. And B, we're going to write the ratios of the corresponding side lengths. So RS over XY is equal to TS over ZY is equal to RT over XZ. And then C, check that the ratios of corresponding side lengths actually are equal. So RS has a length of 20 and XY has a length of 12, so 20 over 12. That should be equal to TS, which is 30, over ZY, which is 18, which should in turn be equal to RT, which is 25, over XZ, which is 15. And if I simplify all these fractions, and you can do this in the calculator, you can type each one in the calculator and see what you get out. This one I can divide both of these by 4, and I get 5/3, which is equal to both of these divided by 6, which is also 5/3, which is equal to both of these divided by 5, which is also 5/3. Okay, in this diagram below, triangle MPN is similar to triangle STR. Write a congruent statement for the angles and an extended proportion for the sides. So again, the angles, we're just going to match up the letters. Angle M is congruent to angle S because they both come first. That means that angle P is congruent to angle T, and angle N is congruent to angle R. Side MN over side SR should be equal to the length of MP over ST, which should be equal to PN over TR. So that's my proportion for the sides. Definition of scale factor. Scale factor is the ratio of corresponding linear measurements of two similar figures. To find scale factor, first you're going to identify pairs of congruent angles. So find what are the congruent angle pairs, set up a fraction of corresponding sides, like this, and then reduce. So you can pick one of these, like we did here, and then simplify the fraction, like we did here. So the scale factor here would have been 5/3. This triangle is 5/3 bigger than that triangle. And let's go ahead and fold this over and take a look at this on the back. So our definition of scale factor is a number that is multiplied by a side length to get its corresponding side length. Corresponding side length. So for example, I've got these two similar triangles. The scale factor from small to large is small triangle divided by large triangle, which is pick two sides that correspond, so 3/9, which simplifies to 1/3. So that's my scale factor from small to large, and my scale factor from large to small is, pick two side lengths, can be the same two, doesn't matter. So 6/2, 6 divided by 2 is 3. And you see how these are reciprocals of each other. A small to large scale factor should be less than 1, and a large to small scale factor should be greater than 1. Greater than 1 is going to make it bigger, less than 1 is going to make it smaller. And the steps are going to be find the corresponding parts, and set them up as a proportion. All right, back inside for the rest of this. Okay, verify that the polygons are similar. So we can see which ones match because of the way they're outlined. C corresponds to F, A corresponds to D, B corresponds to E because of how many lines they have got marked here. So we could tell that, say, AB, which is 2 lines and 3 lines, over DE, 2 lines, 3 lines, that would be 12/15. And that simplifies to 4/5. My other corresponding sides would be BC and EF. BC is 16 and EF is 20. I can divide both of those by 4 and I get 4/5 again. And then AC and DF are proportional because they correspond. AC is 8, DF is 10. I can divide both of these by 2 and I get, again, 4/5. So yes, these are similar polygons. Okay, if I had like here, KL and XY, KL over XY, because these are both rectangles, and KL and XY are the shorter sides of the rectangles, so those should correspond. That would be 10/15. If I divide both of those by 5, I get 2/3. And then the longer sides are KN and WX, KN over WX. Those are 15/20. If I divide both of those by 5, I get 3/4. So those do not simplify to equal the same fraction. That means that these two shapes are not similar because the corresponding sides are not proportional. Okay, we'll skip on past that third one. Now, in this diagram of similar figures, find the value of x. So pick two sides that correspond that we know both the sides, so like ED and NM, 9/12. That should be equal to these two sides that correspond, so that would be x/20, and then we just cross multiply. So 9 times 20 is 180, equals 12 times x, which is 12x, and then we just divide by the 12. 180 divided by 12 is 15. So x equals 15. So if these are similar, as it says they are, they should be proportional. If they're proportional, then x would be 15. Same idea here. Pick two sides like ADQT. So 10/5. That should be equal to x/4. Cross multiply. 10 times 4 is 40, equals 5x. Divide by 5. 40 divided by 5 is 8. X equals 8. And if you look at it, you should see all these numbers are half as big as these numbers. So 10 divided by 2 is 5. 12 divided by 2 is 6. 60 divided by 2 is 8. So that means x must be twice as big as 4, which makes sense.